The indeterminate form infinity to the power of 0, a deeper dive. The expression infinity to the power of 0 is considered an indeterminate form in calculus due to its inherent ambiguity. While the base, infinity, suggests an infinitely large value and the exponent 0 suggests a value of 1, the combination of these two elements leads to a non-unique limit. Key factors contributing to the indeterminacy of infinity to the power of 0. 1. Conflicting trends. The base infinity implies an infinitely large value, while the exponent 0 implies a value of 1. These opposing trends make it impossible to definitively determine the result of the expression. The limit of infinity to the power of 0 can vary depending on the specific functions that approach infinity and 0. For instance, the limits of x to the power of x and 1 divided by x to the power of x as x approaches 0 are different, demonstrating the sensitivity of the expression to the underlying functions. L'Hopital's rule, a powerful technique for evaluating indeterminate forms, is not directly applicable to infinity to the power of 0. This rule requires a quotient of functions, not a power, making it unsuitable for this particular expression. To illustrate the indeterminacy of infinity to the power of 0, consider the following examples. All right, let's dive into our first example. The limit of x to the power of x as x approaches 0 is 1. Now moving on to our next example. The limit of 1 over x to the power of x as x approaches 0 is e. So, in conclusion, the indeterminacy of infinity to the power of 0 arises from the conflicting trends of its components and the sensitivity of its limit to the underlying functions. And finally, understanding the nature of indeterminate forms is crucial for accurate mathematical reasoning and problem solving.